Alright, we're good to go. Alright. Next up, section 4.5, which I'm just going to do it over here. 4.5. We're going to start with number 215. This is all chain rule. So this one has W of x, y, z is equal to xy cosine of z. X is equal to t. Y is equal to t squared, and z is equal to arc sine of t. So, if we all remember the chain rule, hopefully, we will know that dw dt is equal to partial w partial x dx dt plus partial w with respect to y dy over dt plus partial w with respect to z dz over dt. So, partial of w with respect to x is going to be y cosine of z. X with respect to t is going to be 1. Partial of w with respect to y, x cosine z, times 2t. And finally, partial of w with respect to z, negative xy sine z, times dz dt, which is 1 over the square root of 1 minus t squared. And that's going to be it, because apparently we do not have to simplify this as a function of only t. So I'm going to just leave it like this afterwards. 2tx cosine of z minus x y.
Hey, Verda,
Yeah.
so if the question was simplify it like in terms of t, you would have to put
If it
in the
asked you
t
to do that,
terms
then
like
yes, you would have to plug it in. You would have to plug everything in terms of t, and then simplify it.
all right. Thank you.
No problem. Let me see if there's any more questions. Why are they putting stuff from my? Why are they putting old videos from my YouTube channel that are like cringe? Why are they putting the cringe stuff? The recent stuff is way better. Even though by recent I mean like a year ago. I know, but my voice is absolutely cringe in that video. It's cringe. I think that is like you're witnessing like 7th, 8th, or 9th grade me doing stuff. Alright, anyways, tour 17. W is equal to 5x squared plus 2y squared. X is equal to negative 3s plus t. Y is equal to s minus 4t. And then it says to find partial of w with respect to s and partial of w with respect to t. So, we're just going to do the exact same thing we did before. So, but in this case, we have two independent variables, so everything's a partial derivative here. So in this case, first we have partial of w with respect to x times partial of x with respect to s plus partial of w with respect to y times partial of y with respect to s, which is negative 30x plus 4y. Partial of w with respect to t, partial of w with respect to x, partial of x with respect to t, partial of w with respect to y, partial of y with respect to t. 10x minus 16y. And that's going to be it, assuming we're not going to solve for only s and t. $219. So here we have f of xy is equal to xy. X equals to r cosine theta. Y is equal to r sine theta. And it asks us to find partial f with respect to r and partial f with respect to theta. So in this case, we're going to have the same chain rule thing from 217. So partial of f with respect to x, partial of x with respect to r, partial of f with respect to y, partial of y with respect to r. Y cos theta plus x sine theta. Partial f with respect to theta. Partial f with respect to y. And the recording decided to crash. Give me 1 second. Anyways, partial of y of x with respect to theta, that's going to be negative r sine theta. Partial f with respect to y, and partial y with respect to theta. So this is x r cosine theta minus y r sine theta. And that's it. And that's it for this question. All right, next question is 227. So w of x, y, z is equal to x squared plus y squared plus z squared. X is equal to cosine of t, y is equal to sine of t, and z is equal to e to the t. The first thing it asks us to do is to go directly to w as a function of t, and then take the derivative, and then find dw dt using the chain rule. So the first method is w of t, which is cosine squared t plus sine squared t plus e to the t squared. Cosine squared t plus sine squared t is equal to 1. And then e to the t squared is e to the 2t. dw dt is therefore 2e to the 2t. Again, from the chain rule for single variable functions. Now, if I do it the other way, we're going to get partial f with respect w with respect to x times partial x with respect to t plus partial w with respect to y, partial y with respect to t, plus partial of f with respect, not fw with respect to z, partial z with respect to t, which is e to the t. This is one you're probably going to have to plug in, because you're going to have to show that these two are the same thing. So doing that here, x is equal to cosine t. So we get negative 2 cosine t sine t, 2 sine t cosine t, plus 2 e to the t times e to the t. Negative 2 cosine t sine t plus 2 sine t cosine t is 0. And e to the t times e to the t is equal to e to the 2t, so we get 2e to the 2t. The exact same thing we got earlier. $229. U is equal to e to the x sine y. X is equal to negative natural log of 2t. ny is equal to pi t. And then it says to find du over dt evaluated at the point ln2 pi over 4. So first, let's just go find du over dt really quickly. Now, there's two different ways you could do this. The easiest way is to realize you can just plug it in. Oh my god, can you? Oh my god. Recording decided to crash again. Okay. So du over dt. Yeah, we're gonna use the chain rule, or you can just parameterize u as a function of t, which I think is going to be the better option. So e to the negative ln of 2t, and then sine of pi t. So e to the ln of 2t is just going to be equal to t to the negative 2. And then we have sine of pi t. So we could legitimately just take this guy and get it. But let's just try and use the chain rule. So du over dt is going to be e. Oh my god, can you not crash? Please. I'm gonna turn on high performance mode and see if that fixes anything. Yep, we're having some technical issues. Nothing to worry about. Anyways, back to this chain rule. We'll have e to the x sine of y. Ah, you too. I mean, yeah, that's exactly what you're supposed to get. E to the negative ln2 is literally just a half. And oh, it's because that should be 1 over 2t. It should be 1. Oh yeah, that's because it should be 1 over 2t. We got the parentheses, damn it. Alright, back to the chain rule. This is this times partial of x with respect to t. So you can get negative 2 over 2t. Again, same rule as before. Plus partial of u with respect to y times just pi, because it's partial of y with respect to t. Oh yeah, that's because I messed this part up a little bit. This should be e to the ln of 1 over 2t, which is just 1 over 2t like this. Alright, so this is just negative 1 over t, so this is just negative e to the x sine y over t plus pi e to the x cosine of y. And now we just plug it in. Which is at the point ln of 2 pi over 4. Now, the only hard part of this will probably be figuring out t. But here we can just use a system of equations to do this, which we will get. On both cases, you'll get t is equal to 1/4 because negative ln of 2t is equal to ln of 1 over 2t. 1 over 2t is equal to 2. So 2t is equal to 1/2, and therefore t is equal to 1/4. And this should be pretty straightforward. T is equal to 1/4. So that's what we plug in for t on this. So negative e to the ln2 sine of pi over 4 over 1/4 plus pi e to the ln2 cosine of pi over 4, which becomes negative 4 e to the ln2 is just 2, and sine of pi over 4 is root 2 over 2. Pi 2 root 2 over 2. We get negative 8 root 2 over 2, 4 root 2 over 2. 4 root 2, sorry. Plus pi root 2. So we just get root 2 times pi minus. Damn it. It stops screen sharing every single time my computer turns off, so that's always a huge problem. Well, on the bright side, it keeps the HD thing going on for a while. All right, next question. 243. Here, z is equal to x over y. X equals to 2 cosine u. Y is equal to 3 sine of v. dz du and dz dv is what it's asking to find. So first we're going to start with a partial with respect to x of z. Partial of z with respect to x, that's just going to be 1 over y. Partial of x with respect to u, which is negative 2 sine u. Plus, now the partial derivative of y with respect to u is actually equal to 0. So I can just stop right here. Now we have the partial. The partial of x with respect to v is 0. There should be a v. That should definitely be a v. So we're going to skip over the x because we know that's just going to be 0. So partial of z with respect to y. This is going to be negative x over y squared times the partial of y with respect to v. And that's going to be it. And then this is just negative 3x over y squared cosine v. Cool. 245. Z is equal to xy e to the x over y. X equals to r cosine theta. Y is equal to r sine theta. And this wants to find partial of z with respect to r and partial of z with respect to theta when r is equal to 2 and theta is equal to pi over 6. So, starting with this one, we have partial of z with respect to x. We have a product rule on like every single step here. So y e to the x over y plus xy. And then times the derivative of that, which is just going to be x e to the x over y. Here we're just using xy e to the x over y times the derivative of the inside, which is going to be 1 over y, which cancels out the y. Partial of x with respect to r is just cosine theta. Then we have this with respect to y. And then here we have e to xy, e to the x over y, times negative x over y squared, times sine theta. All right, partial with respect to theta is going to be very similar, except instead of cosine theta, we're going to have negative r sine theta. And then instead of sine theta, we're going to have r cosine theta. And now we're just going to evaluate this, which means partial of z with respect to r, pi over 6. Now, it's worth calculating what x and y actually are. So x is equal to 2 cosine of pi over 6, which is going to be root 3. And y is equal to 2 sine of pi over 6, which is 1. Well, this is going to be a while. So this becomes e to the root 3 plus root 3 e to the root 3 times root 3 over 2 plus x e to the x over y, which is just going to be e to the root 3 plus root 3 e to the root 3 times negative root 3. Yeah, that should be able to. Times sine of pi over 6, which is 1/2. Always raging whenever the thing crashes. Alright, and for the interest of time, I'm just going to copy paste these. Negative r sine theta, which is just going to be negative 2 times 1/2, so just negative 1. There should be a plus somewhere. I forgot a plus here. Yeah, plus. Plus. And then r cosine theta is just going to be r times root 3 over 2. Or 2 times root 3 over 2, which is just root 3. And that is it for the question. One more question, and we're done with 4.5. No, no. Oh wait, that was 245. Oh wait, that was 245. Well, I guess we're done. I guess on to 4.6. 4.6. Four out 7. My worst one at 4.6 in the textbook. Alright, first problem up, 263. Which says to find the directional derivative at the point given and the direction given. Point 0, negative 2. And b is equal to 1/2 I plus root 3 over 2j. So the directional derivative, here I can roughly tell that this is going to be a unit vector. Or you can even check for yourself. Magnitude of just v is square root of square root of 1/4 plus 3/4, which is equal to square root of 1, which is 1. Like that. So gradient of f dotted with the unit vector, which is in this case just v. And then we're going to just go ahead and just do partial of x, f with respect to x, which is just y, times the unit times this unit vector here, which is 1/2, partial f with respect to y, times root 3 over 2. And now we just have 0, -2. 1/2 times -2 plus root 3 over 2 times 0, which is equal to -1. (265) h of xyz is equal to xyz plus j minus k. Here the magnitude is not 1, and it's root 6, so we're going to have to get the unit vector first. So it's just 2 over root 6i plus 1 over root 6j minus 1 over root 6k. The gradient dotted is going to be 2 over root 6yz plus 1 over root 6xz minus 1 over root 6xy. Like so. Two over root 6, yz is just 1, xz is 2, and xy is also 2. This one and this one are just going to evaluate to 0, so we just get 2 over root 6 as our answer. Oh, the vertical line means evaluated at. All right, 4.6, number, what is that? 267. That's the one we're solving right now. Sorry if it feels like a fever dream. We just grinding problems out. Alright, it says f of xy is equal to x squared minus y squared. And then our unit vector is equal to root 3 over 2. And 1/2, that's going to be a magnitude of 1, so I do not have to do anything in terms of that. Gradient f dot u, partial with respect to x times root 3 over 2 plus partial with respect to y times u of y. I'm just going to use the directional derivative thing. 1, 0. 2 times 1, root 3 over 2, times 1/2. This portion is 0, so we get root 3. I'm just going to give a few seconds just for everyone to get caught up. Maybe. I will post these probably after we're done with this. That should be 4.5. Let's reload Discord again. So I'm going to see the chat live. 200 and what's the next question? 281. Let's see, what is it? Oh, it's a gradient question. So this one's asking us to find the gradient of f of xyz is equal to xy plus yz plus xz at the point P of 1, 2, 3. So first let's find the gradient of f, which is going to be partial derivative of this whole thing with respect to x, which is going to be y plus z, times I, plus the partial derivative with respect to y, j. I'm using the bracket notation here, so it's just making it a little bit easier. And the partial with respect to z. Partial f evaluated at 1, 2, and 3 is going to be 2 plus 3, 1 plus 3, 1 plus 2 like this, 5, 4, 3. $287. For the following exercises, find the derivative in the direction of u. So this is just your directional derivatives. F of xy is equal to ln of 5x plus 4y, and we're given a 0.39. And in the direction of u, which is equal to 6i plus 8j. The magnitude of u is going to be the square root of 6 squared plus 8 squared, 36 plus 64, which is equal to square root of 100, which is 10. So the unit vector is 6/10 or 3/5 I plus 4/5 j. So now our directional derivative is going to be the gradient of f dotted with the unit vector. So first partial with respect to x, so 5x plus 4y times the derivative of the inside, which is 5, times 3/5 plus the partial with respect to y. Same idea. Partial 1 over the inside times the times the derivative of the inside times 4/5, which is equal to, this gives you 3 over 5x plus 4y plus 16/5 over 5x plus 4y. And then evaluate it at 3, 9. 3 over 5 times 3 plus 4 times 9. Plus 4 times 9 again. 15 plus 36, that is going to be 51. Well, yeah. Which I'm just going to multiply everything by 5 on the top. So 15 over 255 plus 16 over 255, which is going to be 31 over 255. $291, and then we're on to 4.7. It's going to be the worst of this. $291. X e to the y minus ln x, negative 3, 0. This says to find the gradient vector at the indicated point. So gradient of f is going to be partial with respect to x. So e to the y minus 1 over x, comma, partial with respect to y, which is just going to be x e to the y. Partial of f at negative 3, 0, which is just e to the 0 plus 1/3, and then negative 3 e to the 0, which is equal to 1 plus 1/3, so that's going to be 4/3, negative 3. All right, on to 4.7. Just going to give a moment to breathe, and then we're just going to grind this. Oh my god, it's going to be actual suffering for this. Okay, the chat's updated. For some reason, the chat never updates live for me. I think this spoke something sense. In awkward silence. Oh my god. I mean, we could just move on to past exam problems. Exam problems. That would be funny. I didn't even prepare a Kahoot for this. Okay then. I guess you guys could just watch me make a Kahoot. Alright, let's just do this. 311. This is just critical points for now. find all critical points. So we're just going to do the partial derivative with respect to x. So this is just 2 times 3x minus 2 times the derivative of the inside. And then the same thing here. And then I'll set them equal to 0. Here, y minus 4 needs to be 0, and 3x minus 2 is equal to 0. 3x equals to 2, x is equal to 2/3, y is equal to 4. And that's the only critical point. $315. Find the critical points from using algebraic techniques or by examining the form of the question. Alright, wow, let's go. It's actually something I can do. And then verify using partial derivatives. Minus 13. Alright, let me just go ahead and just set this up. Plus 8x minus 5y squared minus 10y. And then we're going to use completing the square. So for completing the square, the idea is first we're going to get just an x squared, or like just a coefficient of 1 on the second degree term. And then we're going to try to make this a square. So here we're going to have x squared minus 8x. So we're going to subtract 16 in order to get this, and then we're going to add 16 back. And then for this one, we're going to have negative 5 times y squared plus 2y, and then we're going to add 1. This is the same thing as subtracting a 5 here, so we're going to add a 5 back. So this is negative x minus 4 squared minus 5 times y plus 1 squared plus 21 minus 13, which is going to be plus 8. So therefore, your critical points are just going to be 4, negative 1. With partial derivatives, we're going to get fx is going to be equal to negative 2x constant plus 8, and fy is equal to negative 10y minus 10, 0. 2x is equal to 8, so x is equal to 4. And here, 10y is equal to negative 10, so y is equal to negative 1. Confirmed. $319. Okay, 319 is use the second derivative test to classify any critical points and determine whether each critical point is a maximum minimum saddle point or nothing. Here we're given f of xy is equal to x squared y squared. Fx is going to be equal to 2xy squared. This is equal to 0. And fy is equal to 2yx squared, which is equal to 0. So here we have 2x equals to 0, or y squared is equal to 0. 2y is equal to 0, or x squared is equal to 0. This pretty much just gives you x equals to 0 and y is equal to 0. No, it's actually or y is equal to 0. So you've got a whole entire lines here that are all critical points. Because either one actually will give it to you. So that should be 0. And then y can be anything. And then we have an entire setup for the x's as well. Or, and then that will work. Oh, the completing the square part? Okay, so here, if you notice, we have the negative x squared plus 8x. First, I'm going to factor out the negative 1 in order to get a coefficient of 1 on the x squared term. So we have negative x squared minus 8x. Then I want to add a constant to that such that the result becomes a square. To do that, we're going to take the second coefficient here, which is this 8 or negative 8. We're going to take half of that and then we're going to square it. And then that's what we need to add to complete the square. Now, because we've added this, quote unquote, we've actually subtracted this, we need to make sure we're adding 0. So we need to add or subtract it out afterwards. We do the same thing for y. All right. 319. 321 from 4.7. This is again another second derivative test. Yes, I forgot to do the second derivative test. It's on the other one. Here, fxx is equal to 2y squared. Fyy is just 2x squared. And fxy is equal to 4xy. So you get d is equal to 2y squared times 2x squared minus 4xy squared. And then on the critical points, at 0, x, 0, y, we're going to get 2y squared, 2 zeros times 0 squared, minus 4 times 0 squared. This is just a 0. And we get the exact same thing on the other one. So it's all inconclusive. All right, let me just go right. Inconclusive. All right, f of xy is equal to 2xy plus 3x plus 4y. Fx is 2y plus 3. And fy is equal to 2x plus 4. Setting them both equal to 0, we get 2y equals to negative 3, y is equal to negative 3 over 2. 2x is equal to negative 4, x is equal to negative 2. So our one crit point is going to be negative 2, negative 3 over 2. Our d is going to be the fxx, which is 0, times fyy, which is 0, times fx minus fxy squared, which is equal to negative 4. To negative 4. Fortunately, it doesn't actually say anything about what happens when you have fxx equal to 0. So we're gonna have to just go min or max. We don't know. We don't know past that. Oh wait, it's less than 0. It's a saddle point. No, it's not this. It's a saddle point. saddle point. .7 number, what is it? 321, 323. Hello, whoever just joined. F of xy is equal to x squared plus 4xy plus y squared. F of fx is equal to 2x plus 4y. And fy is equal to 4x plus 2y, which are both equal to 0. So here we're going to do a substitution. We're going to take the first equation, and then I'm just going to say that this is negative 1/2 x is equal to y. And then plugging in into the other one, we get 4x minus x is equal to 0, 3x equals 0, or x is equal to 0, and therefore y is equal to 0. So our one trig point is 0, 0. Our d is equal to fxx, which is 2, times fyy, which is also 2, minus fxy squared. 4 minus 16, which is negative 12. So this is going to be a saddle point. Awesome. $343. This is where we start to get, which is determine the extreme values and the saddle points. This is basically where things start to get bad. Though not quite for this one. Damn it, get out. Get out. Okay. X is from 0 to 2 pi, non-inclusive. And y is 0 to 2 pi, non-inclusive. Okay, here I'm actually just going to use the fact that sine x goes between negative 1 and 1 to find the extreme values. So your absolute minimum is going to occur at negative 1. Is therefore for this guy is also going to occur at negative 1. And your absolute maximum is going to occur at 1. For negative 1, we want one of these two to be whatever gives us negative 1. So in this case, 3 pi over 2. Pi over 2 is one such point. And then the absolute max is pi, could be occurring at pi over 2, pi over 2. The way you can see this is we essentially want this guy to be exact, one of these to be at least 1, or exactly 1. And the other to be negative 1, if we want the absolute minimum, and the other one to just be 1, if it is the maximum. This is the only way this is going to be anything. This is going to be somewhat fast. Awesome. Let's just go find the saddle points and we'll be good to go. Cosine x sine in y, f of y is equal to sine x cosine of y. It's set them equal to 0. These both have to be equal to 0. So we need either the cosine of x and cosine of y to be 0, or the sines to be both 0. So cosine x equals to 0, or sine of y is equal to 0. Sine of x is equal to 0. Or cosine of y is equal to 0. Now, because these two will not share a 0 at a common point, we're gonna have to make sure these either the cosines are 0 or the sines are both 0. So our critical points are gonna be just, let's see, sine of 0 is just 0. So you have 0, 0. This one's actually out because our intervals do not actually include 0 as a point because of the brackets here. Because this bracket's not a square one. The other one is the cosines, which will have 2. Pi over 2, pi over 2. 2, does that look familiar? Actually, we have 3 or 4. 3 pi over 2 and 3 pi over 2. Pi over 2, 3 pi over 2. And 3 pi over 2 and pi over 2. We already knew from our observations on sine that this one, and this one were our absolute mins and maxes here. So those are our extreme values. So we have 3 pi over 2 and 3 pi over 2 to test. Negative sine x sine of y. Sine x sine of y. Fyy is going to be equal to also negative sine x sine y. And then our fxy is equal to cosine of x cosine of y. So our d, evaluated at 3 pi over 2, 3 pi over 2, is going to be equal to negative sine of 3 pi over 2 is negative 1. And then sine of 3 pi over 2 again is negative 1. Times f of yy, which is negative of the exact same thing, minus f of xy, which is 0, squared. Which is equal to 1. I just realized this should also be over here. Because negative 1 times negative 1 is also just 1. It's just 1 minus 0 squared, or just 1. Here, our fxx is less than 0, so we actually have a maximum. So this is a maximum. So conclusion, there are no saddle points, and these are what you have here. Awesome, and now for the worst part of this. 345 and 347. Find the maximum values of f of xy is equal to x squared plus y squared minus 2y plus 1 on R xy such that x squared plus y squared is less than or equal to 4. Awesome, so let's just go get the crit points. 2x and then 2x minus 2. Or 2y minus 2. Equal to 0, x is equal to 0 here, 2y minus is equal to 2, y is equal to 1. Our critical point is thus 0, 1. Just, okay, nothing happened. Right. So now all we have to do is figure out what this is in terms of this. If it's a local min or max, we'll keep it going. If it's not, if it's a saddle point or inconclusive, it's just out. So fxx is just 2. fyy is equal to 2. And fxy is equal to 0. 2, 2, minus 0 squared. This is equal to 4. And since here the fxx is bigger than 0, we have a local minimum. Now we just have to check the entire region. Which I'm just going to do x squared plus y minus 1 squared, just to make things a little bit easier to see. So it's obvious 0, 1 is the absolute. So based on this, 0, 1 is likely the absolute min. But let's keep going. Now we just have to create a function onto this. So y squared is equal to 4 minus x squared from our region. And so we have to check 2 of these, where y is equal to minus and y is equal to plus. So first we have the f of x times the root 4 minus x squared. We have the x squared plus 4 minus x squared minus 2 times 4 times the square root of 4 minus x squared. Or I'll just use the 1/2 because it's not good looking. Plus a 1. This is x squared plus 4 minus x squared, so this is going to be a 4. Minus 2 root 4 minus x squared plus a 1. And I'm just going to call this g of x. Alright, so now we just need to plug in all of the endpoints, which will be from -2 to 2. Here, it'll be from -2 to 2, and also the same exact thing. -2. I forgot to check the critical points, which is just 1 over 2 root of 4 minus x squared times -2x, yep, which is going to be negative x over this, and then a minus 2, so we get 2x over this. The critical point here is x equals to 0. So we have -2, 0, and 2. So here we have f of 0, 2, f of -2, 0, and f of 2, 0. -2 squared is just going to be 4. Plus -1 squared, which is just going to be 1 itself. So these two are both 5. F of 0, row 2 is going to be 0 plus 1 squared, which is just 1. Oh, and also f of 0, 1 is equal to 0. Next, we're going to take the h of x, which is the other one. h of x, which is equal to f of x negative square root of 4 minus x squared. Also from negative 2 to 2. Then x squared plus also 4 minus x squared. But this time instead of a minus, we have a plus, which doesn't change anything. H prime of x is just going to be the negative of the other one. So we also have a crit point where x is equal to 0. H of negative 2, h of 0, h of 2, and then we're going to have, this one is going to be f of negative 2, 0, f of 0, comma, negative 2, and f of 2, comma, 0. This one is repeat. These two are repeated, so it's both 5. 0 plus negative 3 squared, this is equal to 9. So to recap, the absolute minimum is going to be 0, and the absolute maximum is going to be 9. We still have another one to go. We still have another one of these to go before we're done with this. We're just gonna have to hope that this one just doesn't take that much time to do. Or that the other questions are so fast that we actually have a lot of time for this one. That's just what we're gonna have to hope for. Or the funny backhand solution, where we can completely skip the method. Alright, final one, and then we're done with 4.7. Can actually send these damn notes. Negative 2y over x squared. Oh no. Oh no. At least it's on the same, at least on the same region, so I only have 2 other points, 2 other lines to check. Or really 1, but you kind of have to split it into 2. Fx is equal to, oh my god, quotient rule. Alright, low, d high, high, d low. 4xy over this. X equals to 0 or y equals to 0. Inclusive or it can be both as well. Oh my god. Fy. Squared. So, low, d high, minus high, d low. Square the bottom and away we go. Negative 2x squared minus 2y squared minus 2 plus 4y squared. Squared. And I'm just going to set this equal to 0. So, this means 2y squared minus 2x squared minus 2 is equal to 0. So y squared minus x squared minus 1 is also 0. squared is equal to 1 plus x squared. Oh god, what the heck do I do with this? Okay. Like, you actually can't. And this is for, and that bottom can't even be 0, so you don't even get an undefined condition. This is like, that is a hyperbola of all critical points. Anyways, I'm gonna just do the region on -2 to 2. Because I do not know what to do with that. There's like infinite, that's like, it's like, oh wait, there's only one crit point then. There's only one crit point. 0 and 1 is your crit point. So g of x is equal to f of x comma 4 minus x squared, so we just get -2 root 4 minus x squared. X squared plus 4 minus x squared is just going to become 4, so we're going to get 5. And h of x, which is just going to be f of x comma negative squared, we're going to get a similar 5 on the top, but then on the bottom, and then we're going to get 2 times this. G prime of x is just going to be -2/5 times -x over root 4 minus x squared. It's just 1 over 2 root x times the derivative of the inside, which is just -2x. And the same thing, but with 2/5. These both have critical point x equal to 0. Those two. Now at -2 and 2, this is going to be both equal to 0. Root 4 minus x squared is going to become 0, so the whole thing will end up going to 0. And then we're going to have -2 times root 4 minus 0 squared, or -4/5. For these two, it's actually the same thing. The root 4 minus x squared goes to 0. H of 0 will just give you +4/5. And the final thing I forgot to check, which is f of 0, 1. At 0 and 1, we're going to get -2 times 1 over 0 squared plus 1 squared plus 1, which is -2 over 2, which is -1. And that's our absolute min. And the absolute maximum is 4/5. We're done with chapter 4. We're done with chapter 4. Alright, I'm gonna go get this sent up. Chapter 4 notes. We only have one more section left, and then we're done with every single textbook problem in the recommended. One section to go. Oh my god, there's so much. Give me 1 second. I'm just having to rearrange. I have to rearrange this. There's so many. Oh my god. Hello, whoever just joined. Oh no! Oh no! What is? Why is? What is this? It's taking me a bit. Just. I feel so bad. Probably are. Oh my god, I'm gonna break these up again, aren't I? Hello, whoever just joined. Oh my god, so 3 hours ago. Okay, I'm just gonna have to hope this is enough. That this is enough. It's going to be just enough for it's readable. Yeah, I'm just gonna follow this offer. You know, this is like basically a lot of the 4.7 stuff. Yeah, that's somewhat readable. Please work. Oh my god, give me 1 second. And I have to restart the broadcast. Just give me 1 second, everyone. This is just taking absolutely. Chapter 4 textbook problems. All right, let me just go get the screen share back up, and we'll be going back to chapter 5. All right, the screen share is back. All right, chapter 5. Oh my god. Chapter 5. Textbook problems. All right. That's just 4. Thankfully, there's just 4 problems to go.
Yo, I have a question.
Yeah?
Um, are you good with discrete math?
I'm like okay with it, not that great, but like okay.
Yeah, I was like kind of like struggling with my work.
Like which one? Which one specifically?
like the exam review for the midterm, like the other midterm. Are you in discrete right now or no?
No.
Okay. Wait, are you a first year?
Yes.
Oh shoot, nice.
All right. All right. There's 4 problems to go, and that's every single textbook problem. (5.1) number 13. Which is calculate the integrals by interchanging the order of integration. Okay, because these are rectangular by Fubini's theorem, we can just straight up change them. Plus 3y plus 5 dy dx. Negative 2 to 2. And then this is going to be 2xy plus 3 over 2y squared plus 5y. Evaluated from negative 1 to 1. And this is going to be 2x plus 1 squared is 3 over 2 times 3 over 2 is 2, and then plus.
Wait, why is this the 2 bound?
Because this is a rectangular region, so Fubini's theorem confirms that we can just do that. And,
Okay, yeah.
and also it asks us to do the question tells us to do that. So we do it as long as it's rectangular bounds, because then it's easy. Minus this becomes negative 2x plus a 3 halves again minus 5. So 2x minus negative 2x, that's going to be 4x. The 3 halves cancel, and 5 minus negative 5 is 10. So we get 2x squared plus 10x evaluated from negative 2 to 2, which is 2 times 2 squared plus 10 times 2. Minus 2 times 2 squared plus 10 times negative 2. The 2 times 2 squareds cancel. And 20 minus negative 20 is going to be 40. Number 15, which is a very similar idea. This is like the 50th time this thing has crashed on me. All right, integral from 1 to 27 of the integral from 1 to 2 of cube root of x plus cube root of y dy dx. We're told to switch the bounds, and by Fubini's theorem, I can just switch them. Cube root of x plus cube root of y dx dy. Integral from 1 to 2. This is with respect to x, so this is x to the 1/3. Right? So we're going to get 3/4 x to the 4/3 plus this is just xy to the 1/3. Evaluated from 1 to 27. Three-fourths, 27 to the 4/3 plus 27y to the 1/3 minus 3/4, 1 to the 1/3, 1 to the 4/3 is just 1 plus y to the 1/3. So this is 81 times 1/3 times 3/4 minus 1 times 3/4, so this is 80 times 3/4 plus 26y to the 1/3. Integral from 1 to 2 80 divided by 4 is 20, so we get 60. Which is equal to 60y plus, and then this is going to be 26 times 3/4 y to the 4/3 evaluated from 1 to 2. Which is equal to 120 plus 26 times 3 is 60, 78 over 4. Or 2 to the 4 times 2 to the 4/3. I don't know what that is. Minus 60 plus 78 over 4. Which is equal to 60 plus 78 over 4 times 2 to the 4/3 minus 1. Alright. 2 more left. $21. And here we're allowed to choose the order of integration. Pi over 2, sine of 2x, cosine of 3y, dx dy. I'm just going to leave it as is. So we get negative 1/2 cosine of 2x, cosine of 3y, evaluated from 0 to pi over 2. So this one's going to be negative 1/2 cosine of pi, which is going to be 1. Cosine of pi is negative 1, so we're going to get 1/2. And then we also have times the cosine of 3 pi over 2. No, that's just a cosine of 3y. It stays, it's a constant. Minus cosine of 0 is 1, so we're going to get negative 1/2 cosine of 3y. Which means the integral from 0 to pi of cosine of 3y dy. This is going to be 1/3 sine of 3y evaluated from 0 to pi. 1/3 sine of 3 pi minus 1/3 sine of 0. Sine of 3 pi is 0, sine of 0 is 0, so it's just 0. And number 23. Integral from 1 to e, integral of 1 to e of 1 over x sine ln x. Man, they really wanted me to suffer on this one. Of course. Thank God they still have a U sub. They have a U subs. Sine of ln x over x plus sine of ln y over y dx dy. So I'm just going to u sub out. U equals to ln x, du is equal to 1 over x dx. That's what we got here. Oh, yeah, we're going to have to split this. So we have sine of ln x over x, and then we're going to deal with that one. Plus, and then the same thing with ln y dy. Because we have to split them, there's no two separate integrals. So 1 to e, and then u, ln 1 is 0, ln of e is 1. Sine of u du, dy. And here I'm going to do a swap, so that we have the dy instead of the dx. Because I want to get the u sub in before the x messes anything up. V is equal to ln y, dv is equal to 1 over y dy. This integral is just negative cosine of u from 0 to 1 And then this is the same sine of u, not u, v, dv dx, e negative cosine of 1, and then minus sine of 1, and then minus a negative 1. 1 to e, this just is negative cosine. One to e of 1 minus cosine 1. E, and then this is going to be also 1 minus cosine of 1 here. These are all constants now with respect to that, so I can just say this is going to be 1 minus cosine of 1 times y from 1 to e plus 1 minus cosine of 1 times x evaluated from 1 to e, which is equal to e minus 1 times 1 minus cosine of 1 plus e minus 1 times 1 minus cosine of 1. And our final answer, 2 times e minus 1 times 1 minus cosine of 1. And that's it. That's the last problem. That is every single textbook problem that was recommended in one go. And of course the thing crashes literally as soon as that happens. Alright, I'm gonna go get this set up. And in just about, and in actually a pretty good time. We didn't even hit the 4.5 hour mark. Good thing good thing this is recorded. Holy. You went over energy. I think we started. Alright. Time to put this into notes midterm. And it is sent over. Alright, what should we do now? God, I'm gonna have to actually make one. Am I really gonna have to make a coup on stream? Hold on, let me see if I can actually make one. I already have an account. Give me 1 second. I'm gonna go disable the stream for a little bit. Yeah, oh wait, this is being recorded this is being recorded anyway, so don't care. Okay, we're back at Kahoot. Yeah. Okay. Theme. Let me see. Oh man, the Halloween's under a subscription. I'm gonna use the closest one to it. The costumes are already scaring up enough true. Alright, now I just gotta actually think of questions. Oh.
You could do true or false one.
Yeah, no, I'm just gonna set up a few quiz ones first. Oh, you know what would be funny? If I just have like one where it's just like the slightest little thing. One plus. I'm trying to think of something. I'm just gonna use slugs. Just gonna do that. Yeah, sure. I can just make the Kahoot for the rest of today, and then just get the Kahoot set up by tomorrow. All right. What are we gonna do? What are we gonna do for the rest of the time? Yeah, we could just do some past exam problems. The review ones? Like everything except question 1. Alright, let me just chat. Okay, I'm gonna just first review the polar coordinates equations to 3D graphs and unit circle triangles, and then we'll just go ahead and grind through the exam review problems. So, polar coordinates. They're essentially, these are a way to make circular regions easier to describe. Here, instead of a coordinate of x to y, we'll have r and theta that describe our coordinates. And the formulas we use to convert from one to the other is x equals to r cosine theta, y is equal to r sine theta, r is equal to square root of x squared plus y squared, and theta is equal to tangent inverse for x plus 0 pi or 2 pi depending on quadrant. Alright, that is pretty much the only stuff from polar coordinates you're probably going to need. Equations to 3D graphs. Are you meaning like the quadric surfaces? Because I think we already have that document up.
Yeah.
Okay, we already have some documents up for what those are in the midterm review, so I think you can just go again and go through those. All right, unit circle triangles. This is I think you might be referring to like these ones, where like the hypotenuse is 1,
Yeah.
and then you have this root 2 over 2, root 2 over 2, and then this angle here is pi over 4. And then the other kind is essentially the pi over 3 / pi over 6 one. This angle is pi over 6, this angle is pi over 3. This is a 1. This is root 3 over 2. And this is 1/2 right here. This essentially allows you to get all of the trigonometric values that you're usually supposed to memorize or redraw the whole unit circle. And really, these are the only two you have to actually memorize.
How should I memorize the unit circle?
So the unit circle over here, just gonna draw one. So to start, if you want to memorize the whole unit circle, the first point I'd start would be this point here, which is going to be 1, 0. This is when your theta is equal to 0. Then you have 0, 1. This is theta is equal to pi over 2. Negative 1, 0. Theta is equal to pi. And then here we have 0, negative 1. This is theta is equal to 3 pi over 2. Every 2 pi, this goes through one revolution, so you're going to get the same angles. Alright. And then the only two that you have to memorize, the pi over 4 one, which occurs at root 2 over 2, root 2 over 2, pi over 4. And then the pi over 3 slash pi over 6 one, I'm going to do pi over 3. This occurs at 1/2 root 3 over 2. It's a little bit crowded, but I think you can see 1/2 root 3 over 2 over there. And then every single time when I calculate this on here, you use the reference angle, pi over 4, pi over 3, pi over 6, or whatever. And then just adjust the signs depending on which quadrant you're in. So this one's plus plus. This one is minus plus. This one's minus minus. And this one's plus minus right here. Like this. And then cosine is like x. And sine is like y. And this is pretty much everything you need. Pretty much everything you need from the unit circle. And the rest is just the identities we've already known. It's just identities. Alright, I think that should be enough reveal. Let's just go ahead and grind through the rest of the review problems. Just get them out. Real quick. Oh, like 5 pi over 6. Let me just go ahead and go over that. So 5 pi over 6 is actually very close to pi, like this. And then this angle over here. 5 pi over 6. This should be, this angle here between the x-axis and whatever this line is pi over 6. Because it's pi over 6 away from pi. Not specifically that, but in general, I always get lost. Okay. Okay, the easiest way is to just is usually either to just memorize it, or just remember roughly where at least the pi over 4 line is, and the 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those are typically the easiest ones, since those are right in the middle of the quadrant. And then just to know that pi over 6 is less than pi over 4, pi over 3 is bigger, but in the first, and those two are in the first quadrant, and so on and so forth for all the other angles. Because the pi over 4 is typically the easiest one to use. For the pi over 6 and pi over 3 ones, you can do intervals of pi over 6. And then the pi over 4 ones are pretty much their own thing, and the intervals of pi over 4. Okay, let's go ahead and just do the exam review problems, 2 to 12. So, number 2 asks us to plot the contour maps of f of xy is equal to xy. Okay, so let's just set some values. Set f of xy equal to 0, xy, x is equal to 0, or y is equal to 0. It says plot this time, so I actually have to plot these. So this is going to be the x and y axes. Where were we? Okay, x and y axes. Next, I'm going to go set xy equal to 1. So f of xy equal to 1. xy. Y is equal to 1 over x, and I'm going to set 1 to -1 as well. One of these to -1. Just because it gives us the full picture. Alright, so the green one is going to be like this. This is z is equal to 1. And then outlined in red is going to be the -1. Like this. Z is equal to -1. Like so. Number 3. Number 3 asks us to find all of the first derivatives and all second derivatives for a through d. So f of xy is equal to x cubed plus x squared y plus xy squared plus y cubed. Fx is equal to 3x squared plus 2xy plus y squared. And fy is equal to x squared plus 2xy again plus 3y squared. B. H of xy is equal to sine of e to the y, e to the cosine of x. So h of x, the sine of e to the y is a constant. And then we're going to take the e to the cosine x times the derivative of the inside. So the derivative of cosine x is negative sine x. So we're going to have sine of x here, a negative here. And then e to the cosine of x like so. H of y. Here now the e to the cosine x is a constant, so that stays. And then we're going to have e to the y cosine of e to the y. This is directly from chain rule. E to the cosine of x. I forgot to do the second derivatives. Oh my god, let me just go ahead and do this quickly. 6x plus 2y. Y, and this is 2x plus 6y. Fyx, which is equal to 2x plus 2y. Fxx is, oh my god, that's going to be actually horrible to compute. Fine. Cosine of x, e to the cosine of x. This, and then this again. And then this guy is going to make another negative, so this is going to be a plus. And then this e to the cosine x will now produce another sine x, so I can just do a sine squared of x e to the cosine of x. Fyy will just be e to the y cosine of e to the y, e to the cosine of x, minus, and then e to the 2y sine of e to the y. Give me 1 second for this to load. Okay, we're back. Minus e to the 2y sine of e to the y, e to the cosine of x. And fxy is equal to fyx, which is equal to, with respect to x, this is going to be negative sine of x, e to the y cosine of e to the y. All right. C. R of st is equal to root s plus t. R with respect to s is going to be here. 1 over 2 root this times the derivative of the inside, which is 1. Same thing with r of t. R of st. This time we're dealing with a 1/2 of st to the negative 1/2, so it's going to be another negative 1/2, so this becomes negative 1 over 4. And then we're going to have s plus t to the negative 3 over 2. And because the derivative is 1, we're just going to also have this as r of ts. RSS is actually going to be the exact same thing, because the s plus t is not going to do anything here. It's t to the 3/2. And r of tt is also the same thing. We have a negative 1/2 dropped, and then we subtract 1 from the power. D. So, D is g of uv is equal to cosine of u over v. So, the partial derivatives, gu is equal to, first we're going to do negative sine of u over v times the derivative of the inside, which is going to be 1 over v. GV is the same idea. But in this case, we have the negative sine of u over v. Here, with respect to v, that is negative u over v squared, so you get u over v squared. G of uu is going to be just the derivative of the sine here, which means that we get another 1 over v cosine of u over v again. And then it's going to be a product rule for this guy, g of vv. Oh my god, I have to write it again. Cosine of u over v. G of vv, which is going to become, this guy is going to be negative 2u over v cubed. V squared times, and this is going to be another negative u over v squared cosine of u over v. 2u over v cubed sine of uv minus u squared over v to the 4th cosine of u over v. GUV is equal to GVU, which is equal to, it's going to be a product rule in both, so I'm just going to take the u. 1 over v squared sine of u over v minus 1 over v squared cosine of u over v. This is again just the cosine and then the chain rule, which is 1 over, that should not with respect to v, damn it. With respect to v. Oh no, this is 1 over v squared, but not this guy. That's going to be cosine of uv, negative 1 over v, and then times negative u over v squared. Negative 1 over v, and then times the negative u over v squared, which is 1 over v squared sine of u over v plus u over v cubed cosine of u over v. E, this is only first. f of rst is equal to cosine of rs sine of st. So starting with fr, we're going to get negative sine of rs sine of st. Fs we're going to do last. F of t is going to become cosine of rs cosine of st. And with this one, we have to do the product rule. Oh, I forgot to do the chain on this guy. This should be negative s. And this guy is s. And then here we're going to do the product, which means that we're going to get negative r sine of rs. And then we're going to get plus t cosine of rs cosine of st. F g of xyz is equal to ln of x squared y squared plus 1 over z squared. Gx is equal to 1 over x squared y squared times the derivative of the inside, which is the 2xy squared. This is a constant. So we get 2 over x. G of y is the same thing. So we get 2 over y. Gz is going to become just the derivative of the 1 over z squared here, which is going to become negative 2 over z cubed. Right, 4. F of xy is equal to e to the x squared y plus e to the xy squared. E to the x squared y plus e to the xy squared. A tells us to find the tangent plane, so we're going to first take some partial derivatives. This one is going to be 2xy e to the x squared y. It's another chain rule. And then we're going to have e to the xy squared, which is going to be y squared e to the xy squared. Another chain rule, because the derivative of xy squared with respect to x is y squared. F of y. Here we're going to have the same thing, x squared e to the x squared y, plus another 2xy e to the xy squared this time. Now, we just have to calculate these at the point 1, 1. 1, 1. 1 times 1, e, and then this is just e to the 1. Plus 1e to the 1. This is just 2e plus e, which is 3e. And in here you get the 1e to the 1, and then 2e to the 1, which is just another 3e. So our tangent plane is z is equal to, well, we have to calculate f at 1, 1, which is equal to e to the 1 plus e to the 1. This is 2e. 2e plus 3e times x minus 1 plus 3e times y minus 1. B. F of 1.03 comma 0.98 is equal to 2e plus 3e times 0.03, because 1.03 minus 1 is 1.03, plus 3e times 0.98 minus 1, which is negative 0.02. This is equal to 2e plus 3e times 0.03 minus 0.02, which is equal to 2e plus 3e times 0.01, which is equal to 2.03e. C. Compute the second derivatives. So with the first derivatives already calculated, fxx will have 2y e to the x squared y plus 2xy, and then we have 2xy again, because we have the derivative of this with respect to x, e to the x squared y, plus y squared times y squared again. So y fourth e to the xy squared. 2y e to the x squared y plus 4x squared y squared e to the x squared y plus y to the fourth e to the xy squared. Let me just go check all that. Yeah, 2y and then 2xy times this guy and the derivative with respect to x, and then this is just a constant. So yep, that's all. It's all good. Fyy is going to be something similar. X squared times 2xy. No, not 2xy. X squared. Y squared times y squared e to the x. No, it's x squared. Right, times x squared e to the x squared y plus 2x e to the xy squared plus 2xy times another 2xy e to the xy squared, which is equal to x to the fourth e to the x squared y plus 2x e to the xy squared plus 4x squared y squared e to the xy squared. Fxy. This has two different product rules. So we have 2x e to the x squared y plus 2xy times, this time we have x squared y plus y squared is going to become 2y e to the x this is y squared plus, and then y squared times, with respect to y, that's going to become a 2xy e to the xy squared. So we get 2x e to the x squared y plus 2x cubed y e to the x squared y plus 2y e to the xy squared plus 2xy cubed e to the xy squared. All right. 5. Here they give us f of mr is equal to gm lowercase m over r squared. And then we are given values of m, which is 6 times 10 to the 24 kilograms, and g, which is 6.67 times 10 to the negative 11. And then it wants us to find partial of f with respect to m and with r. They don't give us values of m and r, but m and g, so I'm just going to plug those in and call it a day. So with respect to m, we just get gm over r squared. Partial f with respect to r is going to be equal to, now the gm and the lowercase m is going to be all constants, so we have 1 over r squared. The derivative of that is going to be negative 2 over r cubed. So we get negative 2gm over r cubed. And then evaluated at 6 times 10 to the 24, 6.6. Actually, these are constants. These aren't m and r, though. M is equal to 6 times 10 to the 24. G, 10 to the negative 11, which is equal to 6.67 times 10 to the negative 11 times 6 times 10 to the 24 over r squared. Six times 10 to the 24 over r squared, which is going to become 40.02 times 10 to the 13 over r squared, or 4.002 times 10 to the 14. Doing the same thing except for r. We have negative 2 times 6.67 times 10 to the negative 11, 6 times 10 to the 24 over r cubed, negative 2 times 4.002 times 10 to the 13, 10 to the 14, over r cubed. So negative 8.001 times, not 8.0, 8.004, wow, my brain is decaying, over r cubed. Awesome. Number 6. A. Z is equal to the square root of x squared plus y squared. X is equal to e to the theta, and y is equal to e to the negative theta. And they want us to compute dz over d theta. So partial of z with respect to x, so that's 1 over 2 root of x squared plus y squared times the derivative of the inside, which is going to be 2x, x, at least with respect to x, times the derivative of e to the theta, which is just e to the theta. Yeah, so, and then we get a very similar thing, but for y. And the derivative of e to the negative theta is negative e to the negative theta. So we get x e to the theta over root x squared plus y squared minus y e to the negative theta over root x squared plus y squared. B. Z is equal to x squared minus y squared. X is equal to u plus v over 2. And y is u minus v over 2. And it wants us to compute partial of z with respect to u and partial z with respect to v. Partial z with respect to u is going to be partial of z with respect to x times partial x with respect to u plus partial of z with respect to y come on partial z with respect to y times partial of y with respect to u, which is equal to x minus y. Now, we have the same partial of z with respect to x, partial of z with respect to v, plus partial of y with respect to z, partial z with respect to y, means partial of y with respect to v. And this is going to be x plus y. Alright, let me just go ahead and do this. Good break. C. F of x, y, z is equal to e to the x, y, z sine of z. X is equal to v squared w. Of uw, and z is equal to cosine squared of v squared plus u. And then it says partial f with respect to u, v, and w. The partial of x with respect to u is going to be 0, so I can skip that one. So e to the x, y, z, no. E to the x z sine z times the partial of y with respect to it, which means we get w cosine of uw plus partial with respect to z, e to the xy sine z plus e to the xyz cosine z times z with respect to u, which is equal to e to the x wz sine of z cosine of uw plus e to the xy sine z plus e to the xyz cosine of z. Partial f with respect to v. This time, it is y that will not give us anything. So we have e to the xyz, sine z, times the derivative of x with respect to v, plus the partial with respect to z, times the partial of z with respect to v, which is going to be, let's see, what is that? -2 cosine of v squared sine of v squared times 2v again. So -4v cosine of v squared sine of v squared. And I'm just going to leave it like that. This time z is not going to give us anything, so we get e to the xyz sine z times partial of x with respect to w, which is v squared. And then we have plus the partial with respect to y, which is e to the xz sine of z. And then times the partial of y with respect to w, which is u cosine of u w. I'm just going to leave it like that. Okay, number 7. Find and classify the critical points of f of x, y is equal to e to the x squared plus y squared. So we're going to start with the partial derivatives. E to the x squared plus y squared, and then times the derivative of the inside, which is just 2x. Fy will be very similar to 2y e to the x squared plus y squared. We're going to set these both equal to 0. The exponential cannot be 0, so we have 2x equals to 0 and 2y equals to 0. So x equals to 0 and y equals to 0. Therefore, our critical point is going to be 0, 0. Now I'm going to calculate the d, which is going to be, oh gosh, fxx plus, and then the 2x times 2x again, which is 4x squared e to the x squared plus y squared. times fyy, which is going to be the same idea, minus f of xy squared. 4xy e to the x squared plus y squared. This is 2x times 2y. And then squared. And then evaluated at 0, 0. The only thing that's going to survive on the first term is going to be the 2, because the 4x squared, the x is 0, so that's going to kill it. And then x squared plus y squared is 0, so that's going to be a 1. Same thing with the other term, we're going to get a 2. And then this one just gets killed. So we get 4. Now, because this is bigger than 0 and f(x) is bigger than 0, 0, 0 is a local minimum. All right, time for the worst one on this list. This is the critical points and then the absolute extrema on a trapezoid.
And just skip this one, honestly. For your own sanity.
We still got like another hour, almost 2 hours to go. Plus 1 plus y squared plus y. A is to find and classify all the extrema. So 2x minus 2, everything else is constants. F of y is going to be 2y plus 1 equal to 0 equal to 0. 2x equals to 2, x equals to 1. 2y equals to negative 1, y is equal to negative 1/2. Oh my god. Critical point, we only have 1, negative 1/2. D, fxx is just 2. Fyy is also just 2. And then 0 squared, because fxy is 0. Which means we get 4. 1 negative 1/2 is a local min. Which makes sense, actually, based on this. Now, we just gotta find the absolute extrema of f within the trapezoid. Okay, first let's just draw the trapezoid. Vertices, negative 2, 0. 2, 0. 1, 2, and negative 1, 2. So we have 2 lines. The first one is y is equal to 0. And then y is equal to 2. This one here goes from 2, 0 up to 1, 2. It goes up 2 for every 1. So y is equal to 2x. At negative 2, we need it to be 0. So I'm going to add 4. And then this one is the other way. And then at 2, we need it to also be 0. So add 4 again. So these are going to be... So first we have the crit point. Which is going to be 1 squared minus 2 times 1 plus 1 plus negative 1/2 squared minus 1/2, which is equal to 1 minus 2 plus 1 plus a fourth minus a half. 1 minus 2 plus 1, that's 0. So you get negative 1/4. Oh wait, this isn't even on our trapezoid. We didn't even have to do this one. Alright, we're just going to check the lines. So first, f of x 0 is just equal to x squared minus 2x plus 1. Which is equal to x minus 1 squared. And from here, I can just identify the critical point as x equals to 1. I'm going to name this g of x. H of x is going to be f of x and then 2 come on. H of x is equal to f of x comma 2, which is equal to x squared minus 2x plus 1 plus 2 squared plus 2 again. 4, 2, 6, 7, x squared minus 2x. I'm just actually going to leave it as 6, because then I can just do x minus 1 squared plus 6, and our crit point is x equals to 1. I of x is equal to f of x to x plus 4, which is going to be equal to x squared minus 2x plus 1 plus 2x plus 4 squared plus 2x plus 4. There's a very similar j of x, but for a negative. X squared minus 2x plus 1 plus negative 2x plus 4. 4 squared minus 2x plus 4. This one is x squared minus 2x plus 1 plus 4x squared plus 2 times 2x plus 4. That's going to become 8x, 16x plus 16 again plus 2x plus 4. Let's see, what is this? 5x squared plus 16x and then plus 20. 1. Yep. Yep, that's it. This one is x squared minus 2x plus 1 plus 4x squared again minus 16x plus a 16 again minus 2x plus 4. Also, I prime of x is just 10x plus 16. Critical point is x is equal to negative 5/3. No, not negative 5/3, 8/5. This one is going to be 5x squared. Though we can't have an x negative, so this is out of the table. Actually, we can. We can. This is minus 20x plus 21, which is 5 times x squared minus 4x plus 4 plus 1. So our critical point is x equals negative 2. Right on the boundary. Actually, it is. And then your critical point is just x is equal to 2. All right, now we just plug everything in. G, and then these two had a critical point of 1. I had a critical point of negative 8/5. which is within the boundary. And I'm like, I of negative 8 over 5. I of 2. And J has just 2 of them. Because it happens to be I managed to get away with a critical point. Just managed to get away with the fast critical point method. Alright, G of negative 2, that's going to be clear. At 1, we're going to get 0. At 1 here, we're going to get 6. What other easy ones are there? G of negative 2 is going to be 9. Negative 2 minus 1, and then here is going to be 1. H of negative 2, that's going to be a 9. It's going to be a 9 plus 6, this is 15. H of 2, this is going to be a 7. Another easy one is J of 2, that's going to be equal to 1. Because this entire thing is just going to be 0. And negative 2, that's going to be 4 plus 8 plus 4, which is 16, 81. 81. I of negative 2, which is equal to 5 times negative 2 squared, plus 16 plus 21. Which is equal to 20 minus 32 plus 21. Negative 12, this is going to be 9. I of 2 is 5 times 2. 5 times 2 squared plus 16 times 2 plus 21. 20 plus 32 plus 21. Which is going to be, let's see, what is that? 73. And then I of negative 8 fifths. Let me see if I can just make 5x squared plus 16x plus 21 into our thing. 5 times x squared minus plus 16 over fifths. Plus, we want 256 over 25. Plus 21 minus 256 over 5. So, we get 21 minus 256 over 5. Which I don't have to calculate, because that's not going to actually matter. Because it's not even close to anything we have. Be 6 over 5. Actually, it probably is. I know 250. Unless I calculated something wrong, which it probably did. Because it should just be 0. That's 21, and then we have... Oh, no, that's because this isn't even right. This should be 8 over 5 squared, so 64 over 25, and 64 over 5. That's better. And then this doesn't matter, because that's only about 13-ish. Be 4 over 5, which is a little bit under 13, so I don't have to calculate that one at all. So our absolute minimum is 0. Our absolute maximum is 81. Okay, number 9. A is a bunch of gradient sketching. Okay, the gradient at 0.5, 0.5 is around here-ish. So it's going to point this way. 0.3, 0.8 is going to point this way. 0.9, 0.4, which is roughly here-ish, is going to point this way. Going to point this way. B, there appears to be a max at 0.7, 0.8. Number 10, g of xy is equal to e to the xy plus x. Compute the gradient of g. Gradient y e to the xy plus 1, x e to the xy. Find the directional derivative of g at 1, 0 in the direction of 1, 1 and then in the direction of negative 1, 2. Why, I just forgot to put a. B. So first I'm going to just say u is equal to 1, 1. Magnitude of u is equal to square root of 1 squared plus 1 squared, which is root 2. So unit vector is 1 over root 2, 1 over root 2. And v is equal to negative 1, 2. Of negative 1 squared plus 2 squared, which is equal to root 5. So the unit is going to be negative 1 over root 5, 2 over root 5. Gradient of g applied at 1, 0, dotted with u is equal to, at 1, 0, we're going to have 0 plus 1, so we're going to have 1. And then x e to the xy is just going to evaluate to 1 as well. Which is just going to be 1 over root 2, 1 over root 2. Dotted with v is equal to the same 1, 1, dotted with negative 1 over root 5, 2 over root 5, which is negative 1 over root 5, 2 over root 5. C. What is the direction of maximum increase of g at 2, 1? So this is the gradient of g at 2, 1. which is equal to 2e to the 2 times 1 plus 1. No, it's 1e to the 2. 1 times e to the 2, and then 2e to the 2 times 1. Which is equal to e squared plus 1, 2e squared. And then the magnitude of this is going to be the slope at that point. E squared plus 1 squared plus 2e squared squared. E to the 4th plus 2e squared plus 1 plus 4e to the 4th. 5e to the 4th plus 2e squared plus e to the plus 1 or e to the 0th. All right, 11. Near the end. This is in math. dy dx. 0 to 2 of x squared y plus y cubed over 3, evaluated from 0 to 3. From 3, we get 3x squared plus 3 cubed over 3. That's going to be 9, minus 0. 0 to 2 of 3x squared plus 9 dx. So to x cubed plus 9x evaluated from 0 to 2, which is equal to 2 cubed plus 9 times 2 minus 0, which is equal to 8 plus 18, which is equal to 26. And this is a 3-parter. B. Integrate y minus x over the region bounded by y equals x squared and y is equal to x cubed. Set up the integral both as type 1 and type 2. Okay, so y squared does something like this. Yes, and then cube will do something like this. So this is the region we want, between 0 and 1. That's the x, and then y goes from x cubed to x squared. 0 to 1. 1, and y goes from x cubed to x squared. Of y minus x, and then dy dx. And then the other setup, which has the x equal to the square root of y and x equals to the cube root of y, with y being from 0 to 1. So this one here is equal to integral from x equals to 0 to 1 of y squared over 2 minus xy from x cubed to x squared to 1 of x to the 4th over 2 minus x times x squared, x cubed, minus x to the 6th over 2 minus x to the 4th, which is equal to, and then I'm just going to do this whole integral of x to the 4th over 2. But 2, actually I can save a little bit by doing this. We have a plus x to the 4th, so 3x to the 4th over 2. which is equal to 3 halves and then x to the 5th times 2/5 x to the 5th. No, 1/2 x to the 4th. 3 halves and then integral of x to the 4th, which is going to be 1/5 x to the 5th. Minus x to the 4 over 4 minus 1/2 times the x to the 6th, which is going to be x to the 7 over 7. From 0 to 1. 3 halves times 1/5 is 3 over 10. Minus 1/4. Minus 1/14. Minus, and then zeros. 3/10 minus 1/4 minus 1/14. 3 over, which means that we get 84 over 280 minus 70 over 280 minus 20 over 280. Would be over 280 minus 20 over 280, or negative 6 over 280. I think the actual volume is going to be 6 over that, but I'm not sure what is the issue then. I don't know why using x cubed. X cubed is a little bit smaller. 1/2 cubed is 1/8, 1 squared is 1/4. So this is the right area. 1 squared over 2. Yep, this should be right. C. Integral from 0 to 1. Integral from 0 to 1 of e to the x plus y dx dy. Integral from 0 to 1 of e to the x plus, integral of e to the x plus y is this going to be e to the x plus y actually. Zero to 1, this is on x, so you're going to get e to the 1 plus y minus e to the y, which is equal to e to the y plus 1 minus e to the y evaluated from 0 to 1, which is going to be e squared minus e minus e minus 0. I mean, not 0, 1. Because e squared minus 2e plus 1. 12. So, okay, this is the last question. Integral of f of x, y, dA represents the signed volume between the xy plane y in region D. Represents the area of region D. Technically, the volume between the xy plane and z is equal to 1 in region D. And that's every single one of them. 2 to 12. Probably no one's here anymore. Oh, never mind. Alright, time to get this damn thing submitted. Sent over. I'm gonna get 5 through 7 on their own. Oh, I don't know anymore. Should we just end it here?
I think we're good.
Okay.
Yeah, I think, bro, I think you did enough today. And if you want, maybe like tomorrow. But yeah,
Okay.
I mean, if we need more, you
We're not
pretty
covering
much
Lagrange
it's all required
multipliers.
anyway. So
That's not being covered by the class. If it were be, I would do some Lagrange multiplier problems.
I think you did a lot today, my boy.
Okay. Hey, just under 6 hours of math.
That's crazy.
All right. So we're just
Hey,
done?
but you'll be responding to like DMs and stuff though, right? If you have questions.
Huh? Sure, I guess. I'll still be online for like the most part.
All right, for sure.
I think I remember how to do Lagrange multipliers, so I could just go through it really quickly.
thanks for the review.
Huh?
Yeah, why did you end up doing this, by the way? I'm just curious.
Doing what?
Like, just helping everyone out.
Oh, he's him.
Because it's free review.
But you don't need the review yourself, right?
This
If
is
he
the free
enjoys
review,
this
so I
stuff.
don't need to do anything extra myself.
Oh, okay, okay.
So I benefit.
But it
I
seems like
also
you already knew
benefit.
everything.
So I also benefit from doing this because the best way to learn is to teach someone else.
Hmm.
So I end up benefiting.
Type shit.
No, he just enjoys this stuff.
Huh? Let me me just go see. Let me just go see if I actually remember how to do Lagrange multipliers, or if I need to remember it. I think the idea with Lagrange multipliers was essentially we have a constraint equation. So let's say like x squared plus y squared equals to 16, like this. And then we had some f of xy. Lagrange multipliers. And then the idea is that in order to figure out where the local min and maximum are, we essentially have the gradients of this and then g of xy, as soon as we have a constant here, become scalar multiples of each other. And then the idea of this is to just essentially solve for lambda and then use that to solve for x and y. I think this is how I remember it. I think it's in Paul's online math notes, so go check that one. Go check that one out. Other than that, yeah, that's I think about it. All right, yep, we're gonna end the stream. I'm gonna get the second recordings onto YouTube, and then send it over. All right. Yep. See you all tomorrow.